Hello everybody, this is the Adafruit CircuitPython Weekly for November 12th, 2018. I'm CircuitPython. I'm Scott and I work on CircuitPython for Adafruit. Every week we get together on our Discord channel to talk about what's happening in CircuitPython land. If you want to join, you're welcome to. It happens every Monday at 11 a.m. Pacific, 2 p.m. Eastern on our Discord channel. You can go to the URL adafru.it/discord to join the Discord. We're on there all week, especially in the text chat. So if you do want to talk CircuitPython, don't think that you only have to make Mondays. That's just when this meeting is. It is in the voice channel for CircuitPython along with the text CircuitPython channel as well, not live broadcast. So be aware of that. This meeting is run in 4 main parts. First, we start off with a quick state of CircuitPython and the libraries. We follow that with Hug Reports, which is a chance for us all to say thank you for the cool work that's happened since we've had a chance to say otherwise, or to thank other people before. We do that in a round robin format, which is I will start and then go kind of alphabetically through the list of folks in our voice channel. If you are lurking, just let us know, which means you don't want to actually be called on. Just drop in a text message on the CircuitPython text channel. We'll skip over you. That's all cool. If you don't have a microphone, feel free to type it in and I'll read it off. So that's how we do round robins. And the third section is status updates, and we do that as a round robin as well, which is a bit of what you've been working on in the last week and what you plan on doing in the coming week. It's a really good time for people to give tips and tricks to other folks. So there's that. And then lastly, we'll do what we call In the Weeds, which is any larger forum topic that we want to talk about. Can vary from community stuff to really technical discussions and decisions that we're going to make. So it varies a lot. During the meeting, we take notes. If you want to follow along, the link was posted in the CircuitPython text channel just before. And then if you're listening to this after the fact, you should see either in the YouTube comments or the Dialzone comment on that video, you'll see a link to the notes as well. They go into a common GitHub repository too, so you can look back and see all the ones before. So I think that's it. Yeah, so let's get started on State of CircuitPython. I'll take a time code so that folks can skip through the notes or through the video to what they want to listen to. So State of CircuitPython, first overall, we talk kind of from a statistics view, how the project's going. So we had 31 pull requests merged in the last week. I pulled these stats last night, so they might have changed just a little bit. We had 10 different authors, which is pretty good. And all of those authors look familiar to me, so nobody new, which, we hope to have somebody new every week. And we had 6 reviewers, which is a good number as well. So thank you to all the pull requesters. And then overall, we had 16 closed issues by 5 people and 11 opened by 8 people. So again, really good in terms of getting issues closed. So that's good. And then in summary, if I just had to talk about where we're at, CircuitPython 4.0 Alpha 3 is close to landing with some of the larger changes that will come with 4X. Dan landed the BLE work that Arturo started, which is awesome. And then I swapped the USB stack over to Tiny USB for the SAMDs last week as well. So those are 2 major changes, really putting us in an alpha state, I would say. And then we'll work to refine that and get ourselves to proper stable release. Okay, and then core-wise, so this is just for the CircuitPython repo. Kattni will cover libraries in just a minute. We had 5 pull requests merged, so about half of the total. We have 4 open pull requests. They're listed in the notes, so check the notes if you want to see what 4 of those are. And then issues-wise, we have 61 open issues with 4 closed by 2 people and 5 open by 4 people. So we are up 1 issue, which is not too bad, but it's always good to get those down. Um, Downloads wise, our latest stable release is 3.1.1, and we've had 1,219 total downloads. I didn't look back to see how that compares previously. But as always, the unstable release 4.0 Alpha 2 has 370 total downloads. So it's, again, the stable release gets a lot more traffic. And we have breakdowns by board in the notes and also by language. So if you're interested in that, check that out. Okay, let's go to libraries with Kattni.
So, I want to say we've updated Adabot, and the output is much cleaner and much more accurate. All of the new and empty repos are now listed in their own section and are no longer included in all the checks, so we don't have the same repos listed under 16 different checks when they aren't ready for those checks anyway. So it's making the library tracking issue and the weekly notes much less overwhelming and easier to figure out what the actual issues are. I want to thank Summersoft for all the work that he's been doing with Adabot. That's huge and amazing, and it's been great. So as for the numbers, we have 23 pull requests merged, which is amazing. 7 different authors, 5 different reviewers. Thanks to everybody who participated in that. We currently have 9 open pull requests. We have, for issues, we have 10 closed by 4 people and 5 opened by 4 people. So we are actually down this week, which is a first in a while. We've been hovering around the same number for quite a while, I think. And other than that, like I said, the list of issues with the repos and so on is a much cleaner and much easier to get through. And if you want to help out with any of that, there is a tracking issue, which I've put in the notes and also in the chat, that has in it all of the problems with anything related to libraries. Some of them are very easy fixes. Some of them are more complicated, but if it's something you're interested in helping with, let us know. If you need any help getting started, or feel free to put in a pull request and we can get started reviewing it. That's where we're at.
Awesome. Thank you. And yeah, Summersoft's been doing awesome. Let's get to hug reports.
For the record, the numbers, if you add up the numbers between the core and the libraries, it won't match the overall because I pulled the I re-pulled the library stuff with the new changes to Adabot.
Okay.
So just so you know,
does that mean I ran it wrong?
No, it means you didn't do a pull on it, which actually turned out to be a good thing because there was a bug where it wasn't showing the core info anyway.
Huh. Because I did pull it, I thought. Maybe I didn't merge it. Okay. Yeah, I think I fetched it, but I didn't actually update.
Turns out that was a good thing because we found a bug, which will be fixed next time.
Perfect.
So feel free to pull and merge next time, and then we'll be good to go.
TG Techie, yeah, you can just type in your hug reports, and I will read them off. So if you don't want to speak, just type it in when it's your turn, and I'll read it off. Yeah, thanks, Kattni. I totally meant to update to the latest, but obviously I failed. I'll get that for next week. Okay, so Hug Reports is a chance for folks to say thank you to other folks for the work that they've been doing. First and foremost, that's a really nice thing to do, and so we want to be explicit and do that every week. And then it's also great to do it in a public setting like this because we then reinforce what we value as a community. So if people can figure out like, oh, if I do this, people will be happy, and that's good for us to all know. Okay, so as always, I will start because I will be the example, and then we'll go around down the list and around after that. So first and foremost, I wanted to say, typing my doc and okay. First and foremost, thanks to Dan Halbert for the review on the USB stuff, along with Jerry for the immediate testing and finding of bugs. I knew it wouldn't be bug free, but yeah, it's good to know that we're finding them quickly. So thank you to you both. I wanted to thank Carter for redoing the ADS API. I really, really appreciate that. I know it's not always the most fun thing to go back and work on code that you've already done. Summersoft, thank you for reviewing that code. I appreciate that. Kattni, in general, you've been doing tons of reviews, and I really appreciate that. So thank you for that. Summersoft again. Thank you for I kind of see you as like the maintainer slash mechanic for both CircuitPython build tools and for Adabot now, which is great. Keep doing that, please. It's super helpful. And then lastly, I wanted to thank shout out to Brennan for all of the PyPI and the library work that you've been doing as well. I really appreciate the Raspberry Pi side of things because I don't have the patience for it myself. So yeah, thank you to you all. And we'll move on to TG Techie, who says, let me take a time code. Hugs to Dan, Jerry, Carter, myself, and Summersoft for always being so kind and willing to help. Awesome. And also for helping debug. Cool. Okay, Brennan.
Yeah, just a quick one to Lady Ada for some pointers on libgpio.d stuff. I guess I'll have a little bit more about that in my status update.
Okay, cool. All right, Carter.
Just a massive group one this week. Apologies for not taking better notes to give specific shout outs to people. It's just been the regular round of normal cast of characters being awesome. So group hug.
Awesome. Thank you, Carter. And Brennan, can you remute? I got the fuzz from you again, which is weird.
It's okay. Yeah, sorry. It says I'm muted, but
yeah, I don't know why it does that, but yeah, it's quieter now. Thank you. You showed up as muted too, but I could still hear a fuzz, which I don't know why Discord does that, but it does. All right, C. Grover.
Yeah, I've got a group hug today. It's still just amazing to watch the progress of the team and the community working together. I kind of follow it in the background, I'm still learning, but I think I'm learning more quickly looking at the interactions between the folks, and it's a great forum.
Awesome. Well, thank you so much. Okay, Charles.
Just a general group hug. I haven't been interacting specifically with people, but I just watching. As I have the same feelings as Silver did. Just watching what's going on is amazing to me.
Awesome. Well, thank you both for being here. It's nice to have folks paying attention. All right, Dan.
Sorry, I was looking for the mute button.
No worries.
Yeah. So thank you, Scott, for finishing that huge USB thing, replacing the other USB libraries with tiny USB. So, and we're doing all kinds of refactoring. So there's all kinds of much more shared code across the ports, both for USB and for Flash reading and writing.
Mm-hmm.
And then thanks to Summersoft for, as other people have said, for that really big improvement on the stats, library stats in Adabot. And then thanks to Kattni for continuing to work on the Trellis M4 library, which is really important to make that an easy to use project base.
Yeah, totally.
Okay.
All right, thanks, Dan. Deshipu.
So congratulations on the big refactoring. That's it. Group hack.
Awesome. Thank you, Deshipu. Drew is lurking, I think, because he's traveling. So Jerry.
Yeah, again, congratulations and thanks to Scott for the massive USB update and Dan for reviewing it so well and getting it out there and giving me lots of new things to test and break. So having lots of fun.
Yeah, I left those bugs in so you'd feel accomplished.
I thought so.
It's not that I don't write perfect code. All right, Kattni.
Yeah, considering the last time I found something and your response was, you assume that I write good code. So, hug report to Sedacious for helping a ton with getting me started with Python libraries and then trying to help me better understand arrays and helping me get a demo going. Thanks to Summersoft again for all the AdaBot work. The improvements are amazing. And thanks to Dan for reviewing my demo code, helping to make it better, and getting me started with arrays and list comprehensions, and then working through figuring those out. So thanks a lot for that.
Awesome. All right. Thanks, Katney. Sagittac.
So thanks to Tanit, Summersoft, Niz, Dan, Katney, and probably a bunch of other people I forgot. Basically a group hug for all the help with understanding hardware and debugging.
Awesome. Well, thank you for making it. Happy to see you working hard on stuff. Okay, Sedacious.
Thanks.
Sedacious is typing. Stuff in notes, please. Okay. Sedacious says, to Katney, Scott, C. Grover, NIST, Summersoft, and everyone else who has helped me troubleshoot the issues with the board, who shall not be named, and talked me off the ledge when things went more and more pear-shaped. To C. Grover for the reminder that styrene is a thing that exists. It made my bezel making way easier. And I will copy those to the chat too if people want to see it. Okay, Summersoft.
Yeah, so thanks to Katney for all the AdaBot reviews and ideas. Without the ideas, I would not have been able to do any of that. Thanks to Carter, Katney, Jerry, Deshipu, Dan, Nis, and you, Scott, for Discord support this week. I looked back and there was actually a lot that happened, so thanks for that. Scott for pushing forward on the tiny USB conversion. That was probably a tough slog. And Carter for updating the ADS usage to match the MCP3 library.
Awesome. It's awesome to have you on voice too.
It's weird.
It's awesome. It's good. That means you must have the day off. Okay. Status updates. So status updates is a chance to do another quick round robin like we just did. But this time we're talking about the things that we've been working on in the last week and the things we plan on doing kind of going forwards. This is really useful in case folks are working on similar things that like at the same time or something similar to what you may have done in the past. That is really helpful to give tips and tricks and make sure that everything is going the way that it should for things. So I will start. I have a lot fewer notes than some other people, so which is surprising. Okay, so first and foremost, I looked back. It took me 3 weeks to do the tiny USB stuff. So my status updates before that may not have been that interesting. I wanted to say thanks again to Dan for the review and Jerry for the testing. I got that in, and then Jerry did find some bugs with it immediately. So I fixed one of those at the end of Friday, and then I will be jumping back into a number of issues that kind of have cropped up on master since then. So that will be my next, hopefully 2 days, no more than that. And then after those bugs get run down, I'd like to do an alpha 3 because we've done a lot since alpha 2. And then next on my list is USB MIDI, which is including a new kind of output buffering system compared to the FIFO that we've got in there. Because MIDI is weird in that over USB you have to keep like 4 bytes together when you're transmitting, which is it's weird. And TAC also did get back to me on the pull request I made to Tiny USB. So CircuitPython's actually hooked up to using Tiny USB from my fork rather than from the upstream version that TAC runs. So I'm working on pushing those changes upstream as well. And I need to be responsive on him because we're like opposite time zones. So I'll do like one reply every day, hopefully, and we'll get that in. And so that might take me to Monday next week, between doing the PR, fixing the bugs, and doing MIDI. But then it's on the display. Display is like very successful for showing images at this point on the Hallowing, but it needs to be made more general for all the displays and then also for text in particular. So that is the next big item on my list. Okay, TG Techie, did you want to type stuff in? I know you said you were lurking, but you typed in for Hug Reports. Okay. TG Techie's all good. Okay, that means we go to Brennan.
So start off with, I'm just going to be trying to do a little more general code review on libraries and stuff, even if I don't fully know what's going on.
That's awesome.
Yeah. So what I'm working on specifically this week, first of all, tweaking how we do platform detection on Linux systems to try and make sure that we pick up the Pi Zero and maybe more correctly pick up a couple of other things. I'll have a PR in for that shortly.
Okay.
And then I'm looking at GPIO-D to do GPIO stuff in Blinka. There's sort of an issue here in that it doesn't seem like libgpiod is very widely packaged and definitely is not just available in Raspbian right now. So I need to figure out how to provide that off of PyPI, or maybe just sort of optionally use it if it's available and assume that it'll eventually trickle down through Debian into Raspbian, etc., and then be available. I feel like that could take a while.
Right.
I'm going to do a quick thing. We have a bunch of libraries where we strings a little bit wrong and are missing a space. Fix that. And lastly, my girlfriend has the flu right now, so I'm guessing there's a decent chance I'll be out of commission for a bit this week, but hope to avoid it.
Yeah, hope you do too. It's that time of year, though. All right, thanks, Brendan. Carter.
A couple of things. Did a property style access to threshold settings for the cap touch sensor, the NPR 121, and gotten some good feedback on that, because that was kind of that one's got a lot of flexibility, which means like, all right, how do you actually implement this? And the PR's got some good commentary, so thanks to everyone who chimed in on that. Yeah, like everyone's mentioned, the rewrite of that ADS 1x15 thing, that was to make it comply with the other one, but basically it was just a complete rewrite. But that's in a PR'd with some other good commentary. And then a whole bunch of other minor things that I'm probably missing a bunch, but did a PR to the one wire to add a scan limit, because people were getting a memory allocation issue when they didn't have anything connected, or stuff was just kind of generally hosed. Added the we wrapped up the that pressure sensor, that kind of old pressure sensor, the MPL 115A2, I think it was. Kattni helped out a lot with that, and it's in the bundle, and that's all done. And just a few other things like that.
Awesome.
And there you go.
Those few other things make the world go round. So thank you thank you to everybody who does library work. It's super helpful. It's where the real value is, I think. Okay, C. Grover.
Well, let's see. This week was automating an analog meter tester and characterization tool. I'm teaching a class at a local makerspace on how to recondition analog meters, and needed a quick way to characterize internal resistance and those kinds of things. So use CircuitPython and a M4 Express, an OLED, and a custom analog wing that I made, PCB that I made. And let's just say that Osh Park rocks, by the way. I'll post a video and stuff after I do the Makerspace guide, the printed guide. I've got a trinket version of it. I'll put a photo of that up, though. Projects this week, though, we're going to include wrapping up the code and the enclosure for that musical synthesizer dual gesture controller thing that I talked about last week, where I'm using time of sensors.
Neat.
CircuitPython is plenty fast enough for measuring hand gestures and other things.
Nice.
Then I'm going to experiment with, finally get around to experimenting with the RFM69M0 and CircuitPython. It's one of the many Arduino projects that I'm converting to CircuitPython.
Mm-hmm.
That one doesn't have any real significant time constraints or anything, so I think the CircuitPython code would probably work really well. That's it.
Awesome. Thank you. I love hearing all about all of your projects.
There's always something going on. And that's all in the midst of tearing my studio apart and rebuilding it. I finally picked a DAW for it, so I'm pretty good there.
Awesome. That sounds like a lot of fun.
Oh, yeah.
It sounds expensive, though.
I'm going on the cheap as much as I can. We'll see.
That's good. As much as you can. Yep. Awesome. Well, great to hear, and would love to hear about the studio progress as well. Okay, Charles.
Okay. In reference, I'm very interested in your USB MIDI because right now I'm trying to figure to get started on adapting the modern devices MIDI library to be able to have something to a Python version of that. And I hope I can get it to work because I have the Arduino library. And I'm trying to make it match because I have a bit of code for my ocarina that if I can get that, I can convert it to CircuitPython.
Right. Well, my plan is to only make the USB API level will just be like transmitting bytes and receiving bytes, just as if you did MIDI over a UART.
Yeah. See, what I was thinking of is right now. What I was thinking of doing is using bus.io and passing that object into my library to interface to the serial version.
That's exactly what I'm expecting people to do. So you would just pass in the USB one instead, and it should just work.
Oh, wonderful.
Yeah, that's my goal.
Thank you.
Yeah, perfect. I'm glad you're working ahead of me. All right, Dakota, do you have hug reports and status update? Or are you lurking? Maybe lurking. No?
If I could remember how stuff worked.
No worries.
In general, hugs all around. I'm still not getting very far getting started even at CircuitPython. But I figured the least I could do is keep up with what everyone else is doing and with the distractions. All I got done that's even remotely related this week was I discovered that I had already gotten the Huzzah 32, the Mongoose operating system installed to get, which is not even MicroPython. So it's like, right. So that's where I'm at. But like I say, at least I'm trying to keep up with what everyone else is doing.
Yeah. Interesting. Yeah. Awesome. Well, thanks for letting us know. All right, Dan.
Okay, so I've just been working a lot on BLE. I merged, as mentioned, Arturo's BLE big pull request, and with the expectation that I would be making a few changes to it. So I'm in the midst of those, and like thinking about like I had thought about certain things. Maybe I'm changing my mind on some things, but I'm in the process. I'm actually like learning much more about the BLE use cases as opposed to just the 2-paragraph description of something or other.
Right.
So I'm happy about that, and I'm just going to be continuing to work on that for a while. And then hopefully we can start writing some libraries on top of this general purpose low-level library and really try to start using BLE and testing it out. Okay.
Yeah, for those of folks who didn't realize, that was kind of our plan in terms of this API is like we'll just get it in and we'll evolve it to see where it ends up. So if you're interested in BLE, please, and you have projects that use it, please move to this API and then come up with ideas on how we can make it easier and better and that sort of stuff, how we could evolve it.
Yeah, exactly. Like, yeah, as soon as you start using it, and I need more examples of BLE devices and stuff like that too. So if you haven't, thing you want to try as a strawman project, that would be great.
Cool.
Okay.
Awesome. Thanks, Dan. All right, Deshipu.
So there was a local indie game festival this weekend, and I got some academic teachers who teach game programming interested in Pew Pew. They got a bunch of those, and they are going to inflict them on the students. So hopefully we will see some real life testing. And otherwise, since my laptop is still broken, I will get a new one on Wednesday. I'm pretty much on vacation.
Well, enjoy your vacation. It's important. All right. Thanks to Shippu. We'll skip Drew because he's traveling and go to Jerry.
Yeah, let's see. I've been playing a lot this week with the new Bluefruit SPI library that K-Town put out. Been having a lot of fun with it, using a couple of the NRF51, the Bluefruit SPI friend on a whole bunch of different boards. In fact, just in response to a question from the forum, found out it actually works even with the Circuit Playground Express. It uses almost every pin, every pad.
Yeah.
But it does work. It just got up and running. So that's been a lot of fun. And my goal with that is to actually make some things that I can use then as peripherals that can talk to the BLE stuff on the NR52s. So looking forward to playing with that. Did a little bit of quick testing with it. Just tried to modify the scan program to get it to work with the new API, and it does run. And again, trying to understand what it means, but it works. And then let's see. I have been doing a lot of stuff with Laura, planning to work on a Python version, but it looks like Brent has beat me to that. Brent R is now developing the Python port, so I'll stay out of his way and let that happen. But meanwhile, just doing a lot of playing around with the Arduino side of that, playing with that, and finally did some range testing. Found out I can get easily about a 300-meter range with almost no effort, just by sticking the wires on and having one in the house, and no special effort. So they're working pretty well.
That's awesome.
And that's about it. Otherwise, just playing.
Yeah, as you're using the BLE Spy Friend, think about the API that K-Town has for that and compare it to the BLE.io API that Dan's working on, because ideally it'd be similar to what Charles and I were talking about with MIDI, where we should be able to just drop in BLE.io or the BLE Spy Friend library and just have everything built on top work between the two.
Yeah, although I mean I have to dig into it deeper, but the whole SPI friend is all built on the AT strings, which is quite a whole different way of doing things. But
but maybe like the
rapid.
Yeah, maybe BLE.io needs to be high level so it can match that level. For example.
Someone needs some wrappers. But yeah, okay. I'll
yeah, just keep it in mind that like the goal is to have it be the same.
Yep.
Cool. Thanks, Jerry. All right, Katney.
All right. So last week, I did release and PyPI deployment for the Bluefruit Spy and the BMP 3. It's XX, but it's the 388 chip libraries. Updated the lib tracking issue. Got a bunch of libraries that we missed added to the bundle, so that was good. Checked all the libraries to make sure we added everything to the bundle. I added a new NeoPixel toggle demo to the Trellis M4 repo and finished up the guide page on the Trellis M4 guide for the Adafruit CircuitPython Trellis M4 library to explain rotation and the coordinate layouts with a lot of pictures and so on, so that it's really easy to understand what's what depending on your rotation and how to use the library and so on. This week, we've got Library Monday. I've already updated the library tracking issue, so that's set to go. I will be going through everything to make sure that all the libraries are in the bundle. I think we're up to date, though. I've already started going through all the libraries with updates since the last release and doing a release on them. I initially had considered doing this over multiple days, but it's actually going really, really quickly. So I'm probably just going to finish that today. I think that is a good tracking tool, but it's not a great tracking tool if we don't keep up with it. So
right. And it's a new check, right?
Yes, it is.
Yeah.
So that's I'll get all through all those, and then we will have a list that is accurately, from this point on, places where we've done updates and haven't done releases, because we've been running into issues where people are posting
Right.
things to the forum and saying like, oh, hey, I found that you actually did update this, but it hasn't posted to PyPI, or it hasn't posted to the bundle or whatever, and that's the reason why. So we'll just get that out of the way, and we'll be set to go. One thing we're going to be looking into is adding to Adabot a check to look for the sensor simple test.py examples, because now that we have the examples bundle, that folder is a mess, because there's just examples named all kinds of crazy things, and you have no idea what it's for. So I want to start with a naming convention, with like the sensor or the piece of hardware name underscore and then whatever the demo name is. So either simple test, or if it's something special, call it sensor name something special. So if there's no simple test, it will show up in this check. However, the rest of those will not, and this is going to be a long-term manual fix where we're just going to have to go through.
Would it be better to have the bundle have subfolders instead of all of the examples in one folder? Like examples / driver name / and then all of the...
Maybe. I still think it would be a good idea to have them all start with the sensor name.
But from the perspective of an individual driver, it's just redundant, right?
Not if you like have, suppose you want to run those, you're going to put those in your top level / or something.
That's a good point. Yeah.
Multiple sensors on your board. Yeah.
That's a good point.
So, I mean, it should be fine moving forward, and Cookie Cutter includes the sensor name simple test file in there for you to populate. So the newer libraries shouldn't like have a problem with this.
Yeah.
But this will catch to make sure that we've at least got that in there, and then once we go through and update all this, it should be easy to keep up with it moving forward. It's just going to be over the next 4 weeks or so, or however long it takes, to a couple of times a day go through and rename files.
Right.
Just to get those fixed up, and they also have to check the guides and so on and so forth. So obviously there's extra steps to do.
Yep.
But I think it would be worth it. So
yeah, I agree with you.
That's on my radar for that. So that may do a couple of those today. But I'm going to be filing an issue on Adabot to get that check put in. I already talked to Summersoft about it.
Awesome.
After that, we're going to be finishing up the Raspberry Pi CircuitPython library update for the character LCD guides, get that wrapped up. I'm currently writing a page on the Trellis M4 library, or on the Trellis M4 guide for the NeoPixel toggle demo, which will explain arrays and sets, and how to basically write a piece of code using that library from start to finish. I need to test the LSM9DS0 this week and get the PR that's out right now for SPI added in, and then get that released and get the guide updated. The recent library that we got in, the MPL 115A2, needs to be deployed to PyPI. And then after that, I've got a list of guide updates that are the next on the list of things to do.
Yeah, no shortage of work there.
Not at all.
Cool, keep it up. All right, Sagittac.
All right, so I've put in a few quick, simple PRs to CircuitPython, but what I'm mostly working on is, I guess we'll call it Circuit Rust. So Rust is a low-level systems programming language similar to C and C++, but it has a lot of high-level features, and it basically prevents you from shooting yourself in the foot. So in that domain, I started Circuit Playground Express board definition, and then I moved on to working on a NeoPixel library. So the NeoPixel library right now, it's just similar to CircuitPython and the Arduino libraries. It's just using knobs for timing, which I'm not really happy with. I'd like to use SPI and DMA, so it's more cross-platform and can be used on other different speed microcontrollers.
Right.
So yeah, I've started on hardware abstraction library for DMA, so I can get that going. And SAMD51 hardware abstraction layer on, but I need to work out some clock stuff. And yeah, you can check all that out at this GitHub link.
Awesome. Super exciting. The trade-off for Spy NeoPixels is that it usually takes more RAM, but I think with Rust, you're probably less RAM constrained than we are at CircuitPython.
A little bit, yeah.
Perfect. All right, cool. Excited to hear about that.
Thanks.
All right, Sedacious, which I think I'll read off after I get a time code. So Sedacious says, last week received and assembled the new boards. Didn't work, couldn't figure out issues in the time for a new board rev. Sad face, epic sad face, I guess. Scrapped the first board and assembled the second one that is working great, though the boost converter needs rework before assembly. Learned a lesson: never, ever trust someone else's footprints. Yep. I was thinking about that. I think if we actually had a central repo that people could comment on, like if it was just a GitHub repo, it probably would be better. But it would have to be documented really well. Anyway, interesting problem. Next item is resolved to have a single example of the Blinky cyborg raccoon for display at DesignerCon instead of having some for sale. Started assembly of a base, doing some woodwork to build in the TFT, and made an initial bezel out of styrene. Cool. Lots of projects. Ooh, pictures too. This week, finish up the rest of the base, prep and paint. Working on more animations for the TFT and finalizing code for TFT and LED animations. Oh, there's a video of the cyborg raccoon. I must play it. Oh, it's super short. It's just glowy, which is awesome. Okay, and then it says, pack up the car and drive to Anaheim for DesignerCon, which is designercon.com, and they'll be at booth 1049 for anyone who wants to stop by. That's super good to know. I won't be able to make it because I don't live down there, but if anybody is down there, feel free to stop by. All right, so thank you, Sedacious, and we'll go to Summersoft.
All right, so as it may have been mentioned, I was working on Adabot all week. Put in the new script to reduce validators on new and in-work libraries. Added a script to get library bundle and PyPI download stats. And set up Travis YAML to run Adabot on Travis. That PR's in, and we'll see where we get with that.
Mm-hmm. It's open in a tab. I didn't get to
Give it a really good look.
I will, yeah.
My first one from scratch.
Cool.
Change the top level folder name in the CircuitPython bundle builds. That still needs to be, or to have a new release push so that we can update PyPI, but Katney, I wanted you to look at it, Scott.
Okay.
Before we did that.
Okay.
Added the SPY version to the frame library, and received my particle mesh boards this week, and late last week, and then I've been deep in reading the documentation and the GitHub repo on their firmware for that. That's going to be tricky, I guess, to put CircuitPython on, but we'll give it a shot.
Well, it sounds like it'll be easy to put CircuitPython on, but hard to keep connected with their cloud, right?
Yeah, it'll just turn it into a Feather NRF52 if you just, at the moment, but they've got some stuff that interacts with the cloud, and they've got a lot of peripherals available like AES and stuff that we don't currently have. So, but we'll see. They're I think I understand why they set their firmware up the way that they did, but it's really hard to read through.
Huh. All right. Interesting. I'm still waiting on mine. I'm jealous you got yours.
Well, they're still primarily sitting in the box, so don't be too jealous.
That's what'll happen to mine too.
And then this week, I got some more Adabot stuff to do. I'm gonna put in the simple test check. I already fixed that one bug that Katney found earlier, and then I'm gonna work on handling the timeout stuff for requests.
Mm-hmm.
I think it's a good thing to do, especially with it going up to
I lost you.
Sorry, my phone screen blanked out. And then last thing is I'm going to update the core drivers page with the 20 or so that have been added that we haven't updated that with.
Oh, right. Yeah. That manual page. I really do like that page because it has them in categories, though, which is nice.
Agreed.
Awesome. Well, thank you for all your hard work. Okay, let's thank you everybody for hug reports and status updates. Let's move on to In the Weeds. The way In the Weeds works is some people already got this idea, but you can type topics into the CircuitPython text channel and we'll add them to the queue for people to have a discussion on. There's a couple in there already, so we'll start with those and then we'll grab the other ones as they come in. And I think Kattni is the anonymous blobfish. So thank you.
Go ahead and Google what a blobfish is. This is like the second time that this has happened.
I'll have to do that later. Blobfish is a deep sea fish of the family something something. It inhabits the deep waters off the coast of mainland Australia and Tasmania, as well as the waters of New Zealand, according to Wikipedia.
Just the images of it. It really is a blob of a fish.
Well, that's if you take it out of the water, right? Like, where is that? Anyway. Interesting. Okay, that's what it says on the tin. That's what Brendan says. Okay, so let's start off in the weeds here. Sagittac has one about the SAMD51. Do you want to start?
Sure. Yeah, so basically I'm just trying to figure out how to set up the clocks properly. I basically copied from the SAMD21 and I'm not sure if that's the right approach. Like basically what it's doing is taking the 32 kilohertz oscillator, running that through the multiplier, feeding that into DFL-L, and then feeding that into G clock. Does that sound right?
The DFLL, if you look at the errata for the SAMD51, you can't use it as a locking. Basically, it doesn't work.
Okay, so what do you use instead?
We just use the DFLL in open loop mode.
Well,
okay.
Is the DFLL the thing that multiplies it, or is it that the DPLL? I can never remember.
Well, you could maybe use the DPLL. We haven't tried using the DPLL as the primary clock source.
Well, it has the 48 megahertz source built in. And my understanding is that we divide that down using a G clock to 2 megahertz, and then we boost that 2 megahertz back up to the 120.
Right.
And that's the DPLL that does the boosting, right?
I
think it is.
Yeah, maybe that is. I don't remember. But the main thing is that the DFLL doesn't work properly, is broken on the SAMD51.
Right.
All right.
So you can't sync it against you can't have it locked
to the starter frame, right?
Yeah, to something. I don't even know if it locks. Maybe it locks to USB, but there's this, you can sync things to the USB clock, but it's a real problem.
Yeah, we don't do that.
Yeah.
Okay, interesting.
There's a link to our init code.
Look at the errata. Unfortunately, you'll be very
very sad.
Great. Okay.
But yeah, we do actually have it split out from CircuitPython. It's in the SAMD peripherals directory because Notro did a lot of good work with splitting that out.
Yeah, this looks pretty similar to what I have.
Cool.
Sorry, I looked at your repo a little bit earlier too, and to echo the closed loop issue, I was going to bring that up, and then also too, the SAMD51 renamed some of the registers. It's not sys control, it's OSS control.
Yeah.
So
I'm
take
aware
a look.
of that. The SAMD51 that port is in my fork of the repo, and I've changed all that stuff there.
Okay, I was assuming that was probably the case, but I didn't see it.
Yeah.
Yeah, and then it's really common for, I think I talked with you about this on the Discord, but in general, when when I was porting from Sandy 21 to 51, it was very common that like the 21 would have a weird way of like selecting a particular channel of something, and then and it would share the like configurations per configuration registers per channel. Whereas with the 51, they've just exploded that out, and you basically have one set of registers for every channel, which is way easier to manage.
Offset kind of thing.
Yeah, it's way easier to manage because you then don't need to worry about like writing to a register before you write to another register. Which is really nice. And it makes reading easier as well. But I think you figured that out. Cool. Anything else, Sagittac, on that?
No, that's good. Thanks.
Cool. Awesome. All right, let's go to Dan.
Why don't we go ahead to Carter?
All right, we'll knock Carter out first.
Yeah.
Carter.
Sure. This one may be one that's kind of on Dan's list also, because he's kind of helped out with these. This just basically we used to do it this way. Remember, we used to have flash eraser UF2s. You go to bootloader.
Yep.
You drag it over and it erases your file system, and then you're clean and good to go again. And now that's available through REPL.
Right.
But there have been a few apparent edge cases. I'm not sure if these are real or not. This is where it'd be great for Dan, you chime in and give your thoughts on this, where people have been able to get to bootloader just fine, but they drag over the CP firmware and that seems to go fine, and then it resets, but then they don't see the CircuitPython folder.
That's usually because their main.py has crashed.
Right, so they've kind of painted themselves in a corner, right? And also they can't get to REPL.
Exactly. Yeah. So we have these specialized. So I build like a special build that just erases.
Right, and that solved the problem. That special build you made, they used it cleaned it up, and then they went right back to installing the CP firmware, and they were good to go again. So it seems like we've kind of back shelved all those, and there's a lot of boards we don't have those for, because we're saying, use the REPL approach.
Right.
But maybe we need to still have those available, and also add these custom builds that Dan has been making as one-off, actually have them available in that location.
Yeah, the trouble is the M4 one never actually worked. I thought it did, but it didn't. And so there's some bug in the Arduino code for the QSpy or just the SPY eraser. So I didn't have time or knowledge to fix that. So I could put it on my list. It's like kind of far down, and I don't understand it. It would typically take me a day or two to actually make it work. Somebody with more knowledge might be able to do it, but if you think that it's really, I mean, it would be nice to have, because especially for QSpy, because then it would work on any M4 board because they're all the same, as opposed to having a separate special CPy build for each of 30 different boards or whatever. So I don't really know. I mean, was also trying to think of a way to have CircuitPython guarantee to come up in safe mode.
Right.
And then you would have the REPL, and that's also hard to think about how to do, because it worked. We have it on the CPX because we have extra buttons we can use, but we don't have it on most of the other boards, because anything I can think of to do, like grounding this or something, I wasn't sure about that. So,
Dan?
Yeah.
One thing I've done whenever I run into this problem and I get stuck is I just go into the source code. I think I have to go figure out, remember where it is. It's either in supervisor or somewhere, and force it to recreate the file system. Just basically, there's a line there where it does a bunch of checks, and I just make that if true and just have it rebuild the file system.
Yeah, that's exactly what I did. But these are people who don't.
Oh, it doesn't work on that doesn't work on the M4.
Oh no, that works fine. It's just that
what as a simple thing, and it would make all 30 boards, but would it be worth just doing that once, at some clean stage of the system, like after a 4.1 the next alpha release or something like that, or whatever, and just build the whole set with that in there, and then tuck them away.
Right. That's what I was thinking. Is that, but where do we? Right. There are so many of them.
Yeah.
That that's what I was just wondering about where to do.
Yeah.
So.
But Dan, just to back up a bit, this is kind of. I'm not missing some other way of fixing this problem. There still exists the issue that people can get in this weird state where they don't have an out, right?
Right. And so so we either need a low level, a special UF2 that just does a QSpy erase, and maybe there's some easy way to do that. Maybe there's some easier. We have so many boards to support. I think the problem was that the Arduino code does not do a good job of supporting multiple different kinds of SPI flash chips. It was only set up for 2 or 3, and it wasn't nearly as well generalized as the way we do it in CircuitPython. I mean, maybe I could have a special CircuitPython build that ignores all pins except the QSpy pins, and if CircuitPython, but we don't tell anybody that, it's just an eraser. So maybe that might be the simplest thing to do.
Yeah, I think when you need it, that's an option.
Yeah.
I think Sedacious and I are on the right track. I think actually coming up with a good solution to get into safe mode is an option. Like the Circuit Playground, I actually added it, so if you hold both buttons down when you plug it in, it goes into safe mode. So I think coming up with a way, like Sedacious was brainstorming, like maybe we could come up with just like maybe you triple click it, or you do like double tap and long hold instead of like a short like.
Yeah, I think triple click is kind of interesting. We could probably support triple click. That would probably not be hard to add to UF2, but then we have to make a new UF2 build, which is maybe okay.
Yeah, it's a long term.
Yeah, I mean there is an issue about this already, I think.
Can I throw in an observation here?
Yeah, please.
It's kind of a diversity thing. Sometimes things like triple clicks are hard for some people to accomplish.
Yep.
That might be a little bit manually impaired. So if you can come up with something that's a little easier to do,
right,
that doesn't require dexterity or timing, I'm not always sure what that would be. I wish I could offer an alternative that's obvious, but I can't at the moment off the top of my head. But I just happen to know that triple click for myself is difficult to achieve many times.
Yeah, that's a great point. I know I struggle with the double tap from time to time as well.
Does holding it down on startup do anything? As in, like, you hold it down and then you plug it in? Is that something you can detect?
Well, the problem is that when you actually hold it down, it's literally resetting the microcontroller. So I was just thinking about
software. Yeah, not software.
So like I was just I proposed the double tap and hold, and then I realized like if it was holding, it's not doing anything because it's in a reset state. It's not like I can read it to see if it's down still, so it's tricky.
There's some other ideas about bringing a certain pin low or high that's in that issue also.
Right. We were talking about having like some form of external state.
Right. But in the short run, maybe I should just figure out, I should make some special CircuitPython build that doesn't do anything but erase QSpy flash on the board that it thinks it is. Okay, or something. I don't know.
Is having 2 buttons common across all the boards we want to support?
I think it's uncommon. A lot of our feathers have single buttons because buttons cost money. And
take real estate, yeah.
They take real estate, and they also, like, people can get them confused.
One of the things common between most of the boards is the red LED D13.
Right.
And you may want to consider something like that because it is more universal, and it's one of those things that I know in my case I don't always use it for things. I use it as an LED, and if you use it as an input, instead of just an output. That might be some way that you could tie that into, that master reset you're thinking about.
Like if you did a really long hold, like a 3-second hold on the button, and then when the light comes on.
But there's no way to time how long. There's no way to time the long hold. Because the CPU is literally not running.
It's pulling the reset line on the CPU down. That's what it's doing. So,
but I think
yeah.
I think C. Grover is kind of onto something, because it's usually not, that pin's not usually used because it is usually hooked up to the LED. And if it's on the low end, you could ground it. You could tie it high and be okay and detect that, I think.
Well, I think if you tie it high or low while you're resetting, that might be the way to do that, because then it doesn't. You really don't have to have a lot of dexterity to do that. You just have to either ground the pin, probably ground the pin.
Well, I think grounding it will turn it on, right? Which I guess is okay.
Yeah, as Kattni points out, there's no D13 on the trellis, so that doesn't solve it for all the boards.
Right, but
so, yeah.
The trellis has some other limitations because of the lack of pin out.
But in the short, I mean, maybe it's just worth me looking at the QSPI library and.
Then another suggestion too, instead of worrying about making erasers, is would you want to make a special build for each board that just puts it in safe mode?
That's true.
And that way then you can do any number of things that you need to do, not only erase it.
That's actually a decent idea. Just build safe mode versions of everything.
Yeah.
We definitely need to update the safe mode message if we're going to do that.
Well, yeah, we we have different messages, sub messages, so we can.
Yeah, I mean the only way you're going to get that on there is if you put it on there. So, but
right.
Yeah, it's I guess it's a little more flexible than having one that every time you run it, if you forget to take it off next time, it just erases your flash again. I've done many times.
Right. Yeah, that's a good point, because if you do this like admin build, as Sedacious says, or just like a safe mode build, but we still allow you to like erase the file system.
Yeah.
From there, I think that's a great idea, actually.
And we could make a special release that's that.
Right. And hopefully it wouldn't have to be updated too often.
Right. It would just work whenever we add a new board.
Right. It doesn't need to track. It doesn't need to track every new release.
Right. Right. I'm trying to think if we could use the translator.
Well,
I'm just trying to think about how we get it to build. But I could make such a release.
I would just do another flag. Like just make it another build.
Right, but where do we keep these for people to find them in a release?
I probably wouldn't put them in a release. I'd probably just put them on the Amazon S3 and link to it from a guide in the troubleshooting section.
That's an interesting idea. Okay, yeah, because I could make these builds. I mean, it's not hard to do the build.
We already have the flash eraser section, so we can just replace that with the safe mode build section.
Right. That's a good idea.
Okay. All right. So maybe I'll put that on my list of things to do, or somebody will. I can do it, or if somebody feels like doing that.
So one other idea approach, is there anything in terms of an editable file that could be edited, created in bootloader mode that could be then read as a trigger? So something kind of like boot.py, but that's, the issue is the file system is messed up and that's no longer really available for editing, but do it in the, the board boot folder.
Yeah, I guess
that's not really a folder.
But you could detect if you wrote something else and then save it to memory and then detect it. But I think this suffers from the same issue that Dan was getting at, of like, then we have to update all our bootloaders.
Okay, yeah, so that's not as simple as I'm thinking, because it's not really a folder like you're saying.
Right, yeah.
So all the bootloaders that have to be updated.
It's
okay,
fake.
never mind.
Yeah.
It's fake, and you could add support for special fake files, but I think I actually really like Jerry's idea of doing a safe, just this is safe CircuitPython or something that just people know how to load it, and then they run it and they get what they expect, except their code doesn't actually run.
Right. And I got S3 at write privileges now, so I can upload this easily. So
yeah.
All right.
Cool.
Okay.
Good
All
ideas,
right,
everybody.
That's like a 2-hour project or something, so that doesn't sound too bad. Yeah.
Yeah. Yeah, not hard at all.
Okay. All right, I'll put an issue in for that. Okay.
Cool. Thanks, Dan. And Carter, thanks for bringing it up. Okay, let's go on to Dan's async stuff. I think it's the last topic. If people have other topics, please put them in the chat.
So this is something that I brought it up on an internal list, but I haven't sent because it was too much of a straw man. But it's just kind of a general idea, and I'll assuming how this discussion comes out, I might post this as an issue. But the idea is that MicroPython has interrupt handlers, for instance, and sometimes people ask us, don't you have interrupt handlers? And there are other things that we want to do that are also asynchronous, like right now we do it by polling, or we have modules that do it. So for instance, playing audio files is done in the background, and you can say start and stop it, but there's magic happening in the background. Another example is, besides interrupt handlers, it's just asynchronous events. Like suppose you're an I2C slave device,
right?
But you want to do other things while you're sitting around as an I2C slave device. So how do you get notified that somebody sent you a message because you're an I2C slave? Right now, there is an I2C slave implementation, but it's not turned on most of the time, and you have to ask, is there a message?
Right.
So and then we also talked about using the async IO stuff that's in Python 3.x, which is also implemented at least partially in MicroPython, but it's really complicated. It's like I don't understand it fully, and I've spent a while reading it, and I just to impose that mechanism for people, for our most of our users to use, just seems crazy. It's just too low level. So after thinking about what do people really want to do? Is it really that they want interrupt handlers? Really that they want? What they want to do is find out when asynchronous events happen. And usually you can do that. Right now we sort of do that with polling, but I'd like to kind of come up with a general mechanism for doing that. And the way I think the cleanest way to do it, after looking at, there are a bunch of different ways to do it, like callbacks and stuff. But in MicroPython, in an interrupt handler or in a callback, asynchronous callback, you can't allocate any storage, for instance, because you're in the middle of the storage, because the storage manager isn't reentrant. So you could really break something badly. And this is a really serious problem. But it doesn't prevent you from doing that. So you can really shoot yourself in the foot.
Right. So,
and to have a separate interrupt handler and asynchronous events and all this, can we generalize this? And I think the answer, or at least an answer, could be message queues, which is a kind of a general way of that's used in the outside world in Java and a bunch of places. Right. So the idea is that there's a queue. It can be read or write atomically. Something puts messages on that queue, and you take them off when you're ready.
Right.
Okay, to process it. And when you're ready is probably in a while true loop or some other kind of event loop. And then the idea is that, so when an interrupt handle happens, for instance, instead of actually doing something in the interrupt handler, all you do is put something on a queue that says, hey, an interrupt happened, and maybe it happened at this time, and maybe you have a few details about it if you need to. Or if you get an I2C slave message, oh, let's just put the message on a queue so it can be processed when somebody gets around to it. Or if we got an Ethernet packet,
Right.
let's just put the packet on a queue so that it'll be processed. It might not get processed in time, but we have no guarantee. We don't make any guarantees about real-time responsive CircuitPython.
Right.
In the MicroPython world, they try a little harder about that, but we've avoided that.
Mm-hmm.
So that's the idea, is to use message queues. And there's some issues about putting things on message queues. In fact, because you can't allocate storage, the message queue probably actually has to have a fixed number of slots that are already allocated. And you copy the data that you need into those slots, like a buffer that's an Ethernet packet, or a timestamp if it's an interrupt with maybe which pin it was or something like that.
Right.
But just sort of small things that are bounded in size. And then you can check those queues to see if there's anything on them. You can do that without waiting. You can do that. You can sort of peek at a queue to see if you have anything or not.
Right.
So that's the general idea.
I was gonna ask, have you read the tiny USB source code?
No.
Because this is how it works.
Okay.
Which I really do like. Basically, tiny USB in your interrupts, like, oh, my USB transfer is done. It has a fixed FIFO with structs of events, and you queue an event, say, hey, this transfer is done, and then you have in your main loop, you pull those off the queue. So that's to say that I really do like the style that you're proposing here.
Mm-hmm.
And I think the advantage of it is that by having a kind of universal queue of things, you don't have to pull everything separately, which is nice.
I'm not sure if I can have a universal queue because the slots have to be different sizes or something. But is that what you're thinking of? Is that there's
So
okay.
I think pulse in is actually very much like what you're thinking.
Okay.
Because under the hood, it's a ring buffer of pulse lengths, and you just like see how long it is and pop off of that. So I think it's something that we are starting to do already. But I don't think it's going to convince the interrupt folks. I think that the folks who come to the advanced users who come to us and want interrupts, they're expecting preemption. And as you're talking about, like, preemption has problems and it makes things way more complicated. So I think the philosophy of going towards message queues is the right direction, but I don't think that's going to prevent us from hearing people wanting interrupts. Because the people who are coming to us wanting interrupts are like old school C programmers who'd rather not be doing C. But that's not what they're not our audience, and it's not that simple.
Right. If we can say, like, this is really an XY problem, what do you really want to do here? Right. You want to detect that a pin changed state and respond to it. Right. I mean, its question is sort of like, what's the latency?
Right.
What I'm saying is that no Python code, and part of this, I wrote the manifesto, and the manifesto is really just Python code doesn't run asynchronously.
Right.
Other stuff runs asynchronously, and it can notify the Python code. And the Python code will deal with it in its own good time.
Right.
So
the real question is, how do you organize when you have a number of things that are in that mode? Right.
Yeah.
Which is why I was thinking of it in terms of a universal queue.
I mean, maybe there could be a universal queue where you can pre-allocate. Yeah, I don't know. I mean, you could still pre-allocate the objects. I don't know what it would take to make the storage manager be reentrant. I don't know if that's basically impossible or not, because that would also solve this problem in a different way. But
but I still have issue with, like, if you do preemption, then you have to teach people all about locking and stuff, and that's I still get that wrong.
I think we could still use message queues and be able to if we could allocate storage in the C code that's the interrupt handler, then that would be great. And so, but we don't have to do that yet or something.
So Dan, it sounded like you mentioned like two areas where this demand/request is coming from. One is from users of CircuitPython, right? It happens all the time. People come in and they're like, hey, does CircuitPython support interrupts? I want to do interrupts, etc. And then the other one, it sounded like it was more internal for help with drivers and things, right?
Yes, I guess I would say that. Or
like an
it's
I2C
really like
slave.
we're having trouble. Like somebody wrote this I2C slave. Who wrote that? I forget.
Notro did.
Notro wrote it. Yeah. Notro wrote it, and it's great, but you have to use polling. It has its own polling way of polling.
Right.
Or another really good example that came up, which I haven't even discussed, is that the BluePy library has basically a callback mechanism for when something happens.
Right.
And Arturo's API didn't implement that because there's no way to do that. I mean, it's sort of left out. Something that I was going to do, and it was like, well, what kind of mechanism can I provide here? I can't use callbacks in an asynchronous way, but is there can I come up with some general mechanism like a message queue? Because either you do polling or you do interrupts, right? That's sort of
in general, yes, right.
Right, and if you look at the way async IO provides, it does event loops, but it does it in a really complicated way, and you have to, like, there are calls that create an event loop, and that you attach functions to that. It's just very kind of professional programmer Python, as opposed to.
So these all sound like developer roadblocks, issues and roadblocks that developers going to run into.
Mm-hmm.
Especially the average, the non-professional programmers that we have.
Not our target audience of someone just wanting to have a fun time blinking LEDs.
No. I'm saying that I think that message queues could be explained to somebody who wants to blink LEDs.
Right.
I think this is the only mechanism that there is that we could easily explain. Because you could just say, like, oh, you just have in your while true loop in main, you just check to see if something happened, if a button got pushed or you got a message.
Right. But could they, what roadblocks are they running into in their code where they're learning how to blink LEDs that they really need this additional complexity to overcome?
Oh, they don't need it when they're blinking LEDs, but maybe they need it to read buttons or to get, if they're going to write Bluetooth code or something. I mean, I'm not talking about the people who are the first week that they're programming, but the people who buy our stuff and then want to do interesting projects with it that involve asynchronous events.
Guys?
Yeah.
I know you mentioned you were trying to figure out how to create a universal queue, message queue system.
Mm-hmm.
Why couldn't you implement it the same way you did the bus module? You would create a queue object, right, and pass it to whatever other modules you want to use it in.
I think the answer is we could do that if that's the way we want to go.
We can. The only problem is that putting things on the queue may involve allocating storage, and right now the storage allocator is not reentrant.
Ouch. Okay.
So that's really the problem. Yeah. Unfortunately, I wrote all this up, and I'm kind of like saying it out loud in the wrong order or something. But I have a write-up of this, which I will put in an issue. But I just thought I'd kind of get the original impression from people. Yeah.
That's Dan. That's kind of why I was trying to back up, and it's hard to tersely describe what you're even suggesting. Your simple little write-up is kind of a long email. So back up a bit and why are we even going down this path?
Because I need it.
And you're a developer, though.
But why do you need it for the micro BluePy stuff, right?
Yeah, I need it. I need to provide that functionality for the LEIO.
If I remember right, it's just for connected, right? You can easily poll to see if you're connected or not. Like,
I think there are 3 cases.
okay.
It's called a delegate in BluePy. It's not in. I'm not even sure it's in MicroBluePy, but. Yeah, there are notifications. There's something. I can't remember, but it was that's just an example. It's also the case that we have had people say, like, I'd like to notice. I mean, they can always poll a pin. It's true, but they can't poll a pin if they're looking for a pulse, unless you use pulse. And maybe you could use pulse in, but if they're just looking for a glitch on a pin, like a quick up and down, we don't have a way of doing that right now.
I mean,
because if they just poll the state of the pin, they might miss.
Right.
Okay.
Right.
So
I mean,
so
that's what
ahead.
Gamepad, I think, has tried to do a little bit of that as well.
Right. Gamepad notices if the button went up, even if it went down before you got around looking at it. Yeah. So it's basically an interrupt. Right. So that's an example of a case where. So we'll have some C code that puts these asynchronous events that might get lost otherwise onto a queue, or the example of the Ethernet packets. If we just put the packets on a queue and the queue's not too long, then instead of saying like, oh, did a packet just come in? Let me read it. Like, and maybe there's a special buffering system inside the Ethernet implementation. Well, I can just put the packet on the queue. So any particular application, you can think of, yes, the built-in module could provide a buffering mechanism.
Right.
Like Gamepad or Ethernet could have packets, or what's another, or the BluePy stuff could buffer that stuff and you could poll it.
Right.
But why, if we can do it in a general way, maybe that would be easier. So that's kind of.
Yeah, I mean,
I was just saying, like, all these things provide some kind of message queue mechanism. They use some kind of message queue internally. Okay.
Right.
So. And like you said, that's what TinyUSB does too, but at a really low level. So.
Right. Yeah, I mean, I like that approach.
Yeah.
So. But yeah, I would say for now, like, just use it where you think it's appropriate.
Right. But maybe I'll even see if I can provide interrupts on GPIO pins easily, for instance, using this mechanism. So. And then then when somebody says, but you don't have interrupts, I say, well, here we do, use this.
But I don't think they'll be happy with that, but yeah.
Yeah, that's kind of my fear too, Scott, is the requests coming from user land or from advanced C users who want the real thing.
That's totally true, but at the same time, like, I think for people who are like coming from, say, a web programming background or something, message queues are actually going to be near and kind of homey concept. So, there's a side to it where, like, people who are fairly experienced programmers, but not with local stuff, will find it, I think, pretty useful.
Yeah.
So I brought this up now just to get some initial feedback, and I'll take the email that I wrote and turn it into an issue.
Okay.
I just thought if I posted it as an issue, it wouldn't have context.
Right.
And I wrote it up on Sunday morning because I couldn't sleep at 4 a.m, and I was thinking.
Well, that's kind of an interesting question. Is there not already some kind of issue that's been put up in the CP repo about I want interrupts along those lines?
Yeah, so I'll cross-reference.
I'm surprised there isn't one already.
I think there is.
Yeah.
There's at least an async one that's assigned to Wolf.
But that's specifically about implementing async IO.
Right.
Yeah.
But I think the thing I would push you on this is, like, make sure it's grounded in, like, the use cases. Like, message queues are great generally is something we all can agree on, but where it actually impacts CircuitPython is interesting as well.
Yeah, yeah.
So specific BLE cases, specific like proposals for like pin interrupts and that sort of thing would be really helpful to drive the discussion.
Okay, so I'll revise what I wrote initially to be a little more concrete. I mean, it is concrete. It's just the examples are
and as an overall generalization, is it fair to say that polling works great to a point, to where the speed of the thing that you're polling is too fast for you to catch, at which point you want an interrupt?
Yes, and if there's something that is really fast, then we've tended to just we've written C code that handles those interrupts in Python. You never see them in Python.
Right.
So, audio in or something like that.
And then the next level beyond that is where it gets too fast for a software-based interrupt to handle. Then you want a hardware interrupt.
No, but I mean, we do it with interrupts. It's just that we provide an abstraction that hides all that.
Right.
So that it fills up a buffer with the data that you want.
But for someone that's trying to understand it, it's like, this is why it's okay to use polling up to this point, and then this is why polling doesn't work after this point. It's because of the timing that's involved, and that kind of lets them see why it would be okay to try doing it one way to a point, but then past that point, you're banging your head against the wall.
Yeah. Right. So but I wanted to solve certain use cases, because the cases I've seen, for instance, where people want interrupts, they could be solved with polling.
Right.
Right, and it might be clearer for them to see if you give them the overall generalization rather than just giving them the specific use case.
Right.
If they don't understand what the use case is, they're not going to get the.
Right. I'm saying, they say they want an interrupt handler. What they really want is notification of asynchronous something or other. So I'm saying this is the way to do that. Yeah, this is a way to do it. Yeah.
And then the other piece I would put into the stew of thinking about all this is thinking about how it relates to putting the microcontroller to sleep. Because we don't have a great way of saying wait until a pin changes and then wake up again. And polling is particularly bad at that because it is the model that it's running perpetually. So if that is something we can get from this and it's easy to understand, that's good too.
That would be right. So there could be the wake up queue or something like that, or whatever, or it's an event in the.
Or you just like you have a function on your queue that says sleep until blah or wait until there's a new one, where you're explicitly saying like, I don't need to do anything else. Like, let me just wait until an event comes in, and then we can in the background actually go to sleep. And then
I see what you're saying.
And we can manage all of the external interrupt and sleep mode stuff internally. But the model from the user's perspective is just like, my code's not doing anything until I wait until I hear an event on this queue or something.
Yeah.
And then that's an opportunity for us to actually sleep. If assuming that the event underneath the hood is driven by something that can wake up this MCU, but that's something we could manage under the hood, which would be nice.
All right, I'll write that down too.
Yeah, just another thing to consider.
Right.
And that's one thing I've been thinking about in terms of how the async IO stuff works as well. I think it is eventually it's up to the event queue to manage.
Right.
It's just a question of like how you get things on that event queue, which is what async IO does with await or whatever, or async calls.
Yeah.
Anyway, lots of good food for thought. Definitely not something imminent, I don't think.
No, this will have the long-term test. Yeah.
All right, let's move on. We're an hour and a half in, which is pretty wild. But I think TG Techie just added briefly, when a module is deleted, is the imported Py text file removed from RAM. So the text file never really makes it to RAM, but I think what you mean is like all of the data structures for the module itself. And it's complicated. because it depends on all of the references. I think in theory, if you delete the module, it should delete it from sys.modules. Oh, I should put a time code, which should then be able to be garbage collected. But that doesn't mean there might not be another place that is referring to the module that's keeping it around. So it's tricky. I don't think we handle it well. I don't think it works that way. And then I think Dakota as well, you said you wanted to talk about scheduling the review learn stream thing.
Possibly, if it was an opportune moment, and it may not be, being that we've already spent an hour and a half here.
I mean, when works for you?
I got nothing but time.
Okay, well, today I don't have a lot of time. But yeah, let's what do you think the best forum for this is?
Oh, I didn't know if maybe an after the weeds, 5 or 10 minute, let's try something and see how it works out approach would work, because we'd already have a bunch of people here.
Right.
And maybe 5 minutes is enough just to try something. Like I say, I'm really clueless as to how this process works at this point.
For the reviews.
Yeah.
How about we file an issue, and that's where we can collect everybody who's interested in it and figure out a time that works. I would do it today, but I'm already kind of crunched on time. So, would you mind filing an issue, Dakota? And I think we have...
I would if I knew what that was, but why don't you give me until next Monday to figure out what that is, and maybe we'll do an after the weeds how to file an issue.
Actually,
that one's easy enough. I can hang out after the weeds and we can go through that.
Okay.
It's just a matter of filing an issue to get the ball rolling. And but what repo were you talking about, Scott?
Just on the CircuitPython one.
Okay, yeah, no problem.
I think there is actually, there's an event label. You can put it on. That's just like the central place to get people coordinated, so that's fine. All right, well, Carter will do that, and I'll take a time code, wrap up, and then drop out. So let's do that. So thank you everybody for coming to the Adafruit CircuitPython Weekly for November 12th, 2018. This happens every week or nearly every week at Mondays at 11 a.m. Pacific, 2 p.m. Eastern on the Adafruit Discord. You can join the Discord by going to the URL adafru.it/discord. Drop in the CircuitPython text chat and say hi. And then we will be in the voice chat for the meeting itself. You just drop in there and we go around the room, so to speak. They are recorded by the person running the meeting and posted onto the Adafruit YouTube channel and also Diode Zone. You can get links to that dropped in. You'll see links dropped in the CircuitPython text channel after the fact of that. And we also have a GitHub repository of all the meeting notes, so you can check that out as well. We do have notes, so you can skip around in the audio/video if you don't want to listen to all hour and a half of it in this case. And there was one other thing I was going to say and I couldn't remember. I think that's it. So we'll wrap up. Thank you, and we should be able to talk with everybody this time or so next week. Thanks, everybody.
Thanks, everyone.
Thanks, everyone. Have a good week.
Have a good one.